Good afternoon, everyone. Thanks for joining us today for our expert session, How to Reduce AM Costs When Productivity and Part Quality Are Essential. My name's Diane. I'm part of the marketing team here at Prodways. Just a few housekeeping items before we begin today's webinar. All participants are in listen-only mode and your microphone will be muted, but we do encourage your questions. Please submit any questions by typing them into the lower right-hand corner of the toolbox panel, and we'll do our best to answer them during the Q&A session at the end. You will be receiving a follow-up email with a link to today's recording. Now I'd like to introduce Alban, CEO of Prodways Tech. Alban has more than 15 years of expertise in strategic business development in the high-tech industry, and he's been overseeing the development and launch of Prodways key products for additive manufacturing since 2015. Alban, I'll hand it over to you.
Thank you, Diane, and welcome everyone. So the topic for today we'll be discussing is how to reduce additive manufacturing costs while maintaining productivity and part quality, which are essential in digital manufacturing. Before I jumpstart on this topic, just a few words to scope also what we will be covering today about Prodways. We are working on delivering integrated 3D printing and digital manufacturing, so with a heavy focus on how do you use additive as a manufacturing solution and with a high throughput and productivity to make our customer create their business, make a profitable and efficient, innovative business out of 3D printing and offering the full digital business line. In terms of printers, we have 3 product lines: wax drop and demand with the Solidescape brand, plastic powder laser sintering printers, and resin moving light DLP printers. Today, I will be focusing on the plastic powder laser sintering and the moving light DLP products, which are the one most commonly used in industrial application and digital manufacturing. So the topic today also is about how do we make sure that we work with our customer priority while we continue to develop our 3D printer and continue to innovate to make sure that we maintain this high quality, high throughput, and continue to drive the adoption of additive manufacturing while lowering the AM costs. So what are the challenges of the digital factory today? What are the challenges that you're facing when you onboard 3D printing as the first printer to use it as a manufacturing solution, or as you scale up and onboard more and more printers to manufacture what you have to do? So the first aspect that we are looking at and considering is productivity. And already productivity has to be explored according to various considerations. How many parts per job can you do? How many parts per day can you do? Which is a different view of the productivity, but also overall throughout the year, what is the utilization rate of your printer? How many hours per year have you been using the printer? What is the time off that you have using this printer? So we'll get a deep dive on these topics. In terms of cost per parts, again, there is various ways to look at the cost per part. You can look at the amount of material that you have been using to build that part, but you also need to look at the fully loaded cost per part, where you get the amortization and maintenance of the printer that is taken into account, consumable, but also other side effects, so that's the inefficiency of your printer and the hidden costs that you may see in using the printer. Finally, part quality, that's an essential aspect of 3D printing. Of course, 3D printing will give you a lot of unique features, like the ability to manufacture individual parts, the ability to manufacture any volume of parts. But quality is also a challenge compared to traditional manufacturing solutions, such as injection molding for plastics. And so we want to have the highest possible resolution to maintain details. We need to keep accuracy, have a nice surface finish, and also part of the quality is also the repeatability. How do you make sure that all the parts are the same from one printer to another, one day to another, or from one corner to the other corner of the manufacturing? So these are all the topic we'll look at in detail. I will be focusing the example on, as I said, these two printers. The LD Dental series is a moving light printer from Prodways, which is a resin-based SLA printer, and the ProMaker P1000X, which is our latest addition in the SLS family, and that is now available at full scale with all our material. So let's start with productivity. The first level that you want to consider to make sure that you have the highest possible productivity is at the printer level, at the job level. And for that, that's simple. You want to look at the technical spec of the machine when you look at different machines. So, and usually this productivity of the printer is directly related to the power of your machine, whether it's a watt for the laser, watt for the lighting engine in a SLA or DLP printer. All that will give you how fast do you transfer energy to the material to make a part. Also, the build envelope will give you more volume and will allow you to make a better use of the same job. So that's two aspects that you want to consider. Second, you want to look in terms of productivity at the full cycle. How long does it take to prepare? Because if you can print in 1 hour, but if it takes you 1 hour to prepare the printer, that really is the cycle that you want to look at. How fast can you reuse the printer? So it's very important that you take a good care in listening all the cycle and all the steps when using the printer, and also think about the operation that can be done during night and weekends. How do you optimize the long weekend print? That's also a topic to consider when you look at the full cycle. And then you have the larger scale, the production scale, and this is a small example of a chronogram that some of our customers are doing to evaluate how they're going to use and assess the printer. And it's important to understand what can be parallelized. If you have two printers, you may have the same person reloading one while the other one is printing and so on. And also, automation is the next step to improve your productivity. So you want to make sure that there is a path to automation with the printer that you are using. So a few illustrations of this consideration on the product I was mentioning. On the moving light, typically an example, we have the LD20 that has two projectors, so that gives you twice the wattage and twice the power. And as a result, the printer has 35% more speed. Only 35% because the printer is not always lighting. There are other steps where platform move and material is put back on the next layer. So that explains the difference. We also have worked on the software to play with the various layer thickness, various build styles, allowing for more speed. And same example on the P1000, and we'll see it on this video. The P1000X is an evolution of the P1000. It has been optimized with a new software approach, but also a new laser. And you can see the comparison on the left side, which is the P1000X, and the right side, which is the P1000. The video is now in real time. And with the new software and power, we actually achieved twice the speed on the P1000X compared to the P1000. So, of course, there are many other aspects to consider when you look at the overall picture, but you can see immediately that comparing item to item from one printer to another, you will be able to make sure that you get the productivity you want, whether it's from a single job to the entire week, and assuming how many parts per day you need to manufacture. And that's actually the target you usually consider is how many jobs or parts you want to do, and you should build your solution from there. So yes, as you see, the image on the right is just finishing the layer, while the image on the left is finishing the second layer, and that's really the example of difference that we have. So let's talk now about the part quality and what does it mean for 3D printing part quality. So the first aspect is, again, the core specs about resolution and accuracy, and I should say also precision. So what is the smallest detail you can print, and also think about surface finish, and also all these printers, whether it's laser-based, image-based, they all have the ability to have the right software and algorithm to improve the way the energy is transferred to the material to get better surface finish. So you want to check the technical specs again. Usually only resolution is mentioned, but sometimes people give accuracy detail, repeatability, how can you get the same position of the laser beam, and that will give you the right understanding of the kind of resolution you can achieve. Also important factor, the quality can depend on material. So the instruction for use is the kind of document that is provided with the material, will give you detail about what is the minimum wall thickness feature that you can represent with the material. And also, especially with powders, they are not exactly all the same granulometry, depending on their manufacturing process, and some material will provide a smoother surface finish than other. So that's a starting point. Second, it's about the repeatability, because if you get a nice part, how do you make sure that all the parts that you will produce from on the same day on two printers that are sitting next to each other and across the year and across the build platform. So for that, it's really about how the printer was designed, and there's two aspects. Indeed, strong industrial design will give you reliability and repeatability. You don't want the printer to age or move away from its original target too fast. Second, and important, is the process monitoring. So with printers that embed a closed loop control, you will make sure that you can see and measure that you get accuracy. Finally, it's important, post-processing, surface finishing, sandblasting, tumbling, or post-treatment like vapor smoothing, coatings are a way to improve the aesthetics or even application-oriented aspect of the parts. And that's something that needs to be considered fully in the picture of 3D printing. Some extra steps are very light. Additional steps might be as important as the 3D printing itself, but that will help you to get the final product that you need. And I'll show you some example at the end. Few illustration of this aspect about quality. Again, on the LD Dental series, we recently released a software upgrade for 2021 that is called 3D Super Resolution. And you can see the comparison that gives a better surface finish using the light engine. On the P1000, the P1000X has the new thermal field control advanced and improved integrated slicer and camera, and that will give you this. So this is an example again of how it works. You can see the image on the right that has the slicing update as the printer is building, and in the background the thermal control that will make sure that we stay within boundaries and will guarantee the bed stability, which is the key factor for good parts from one corner to another. So this is an example of this closed loop system. But again, the algorithms on the slicing and the beam management are important for the part quality. So now that we've explored how to control the quality and the productivity, we've added a lot of great features, and that may be more expensive features because you have a more powerful laser, you have a more advanced control. So how do you make a total cost per part that is under control? How do you measure it? And what are the observables that you want to look at? Again, the first level is about printer operation. You want to also consider everything, amortization and maintenance, know about the failure rate of the printer, and also keep an eye on the ancillary equipment. If it's the first printer you're going to acquire or use, there might be a requirement to invest in additional equipment. That's an extra capex, but you might also share it with the next printers. So here, I would say talk to your other users. Of course, we'll tell you that our printer is working as it's supposed to work. And but we have plenty of happy users that have been able to use a Movilac printer 24 hours a day, and that will give you a good sense of what it means to operate that printer. And also, you want to look at your yearly budget. Do not forget to include your maintenance for industrial printer. That's an essential step in your quality of operation and avoiding failure rate to maintain the equipment. From the part size, it's very important that you explore the refresh rate and any waste that is generated by the process that's often underestimated, and look also at all consumables. Some printer may also need you to change the bat, change the paper tape, whatever, and so you want to look at everything that is a consumable. Create your own ROI, create your sheet and measure it. We provide ROI sheets, but you might want to create your own. And typically a refresh rate on a material that is 10% versus 50%, well, the volume of the part will be the same. So what you use to build your part will be the same, but in fact, your ROI will be extremely different because you will not have the same amount of recyclability. Second, also something that we've observed with every customer, your ROI will improve over time, no matter what, because you will know more about the printer, because we will work together to improve what you can do with the printer and fine-tune it to your application. That's something you will see progress over time, so that's a good news for you. Final aspects about the cost per part and the total budget is any other hidden costs. So make sure that you've considered every steps. Let's talk about cleaning. That can be a costly step, whether because there is a lot of labor involved, whether there is an expensive solvent, disposal cost. So that's area that you want to explore. Time to learn also is money. If you onboard a printer and you have a project, it takes you 6 months to learn how to get where you want to go. That's going to cost you money. You will not see it, but that's hidden cost in your project. And also the final part is what can you do with your printer? If your printer can only do for your company a single task, then that's an investment that you will have to amortize on a single project. If you have versatility, multiple material, multiple use, you will quickly improve the ROI and the amortization of your capital expense will be much better on your project. So for all this, I would say make sure that you look at the complete solution and that you buy a solution. You don't want to buy a piece of metal that has a sticker that says 3D printer. You really want to make sure that you buy a solution that will manufacture and get what you want to get from the printer. Again, a few examples of how the LD series and P1000 can help along this direction. The LD series is a very robust industrial printer, long longevity components. The LED can live for 30 years. It has a simple maintenance visit. And as example, we offer a granite platform that will allow you to not have any support when you print dental parts. So that's a waste that is eliminated, no support. On the P1000, again, a few examples, our TPU material has a 10% refresh rate only, meaning that you only need to add 10% of new material to the blend for the next print. You will use all the material that you are having in the printer, and that's a great usage level for the material. And again, there are very simple peripheral equipment to use. Of course, more manual steps. That's the trade-off between your cost per part depending on your volume, manufacturing scale. And again, as I was mentioning, think about everything you can do with the printer, because when you have here the example of this large portfolio of material, the TPU, the PP, the PA12, P11, medical grade, glass field, all these material being available in the same printer, it means that the versatility will be a way to amortize better your project and do more with what you have in-house. So that's an important aspect. So now let's work into a few customer example that have leveraged the P1000X as their solution to go with 3D printing and additive manufacturing. Sculpteo is the French service bureau. They needed to onboard new application, new material, and in particular with polypropylene. And they went with the P1000X with the new PP1200. The printer natively runs PP. It was qualified for it, so there was no learning curve on how to bring a new material with the printer. The 2 liters per hour was what they needed with this material, and the investment with the P1000 being one of the lowest entry point into the market was what they needed to explore this new area. So you have some example of what they could build, and it was really a seamless integration for them. Another example, McLeod. McLeod is manufacturing sports tracker for rugby, football, and horse racing. So they needed to make short run, they needed a good finish look product, and that was also impact resistant for these kind of sports. So here we qualified the PA11 that has the robustness but also some elasticity, and they could run a large batch of print in a single job because of the big volume, and the material was performing well with the post-processing step that were added after the printing, and then they brought the final product met all their expectations. They are now happy with their decision to in-house the design versus buying finished part outside. The final example, Namitech. It's a service bureau in Italy, and Namitech was working around prototyping and needed to explore many different materials and have flexibility in their production line for prototype parts. Here they own 3 printers, a large format, and an entry with the P1000. They're in PP, TPU, PA12, PA11, and they were able to leverage all these material across their install base and get all these example parts on this project to fit the different need, whether it's elasticity, it's the polypropylene requirements, or mineral field PA6 that you may require in more stronger parts for the project. And all that with the finish, surface finish, part finish, but also detail that when they wanted. So that was their solution. I mean, as a conclusion, we know that finding the right printer and making your project going where it's supposed to be in terms of cost is a long journey, and we're trying to work with all our customers to create this framework. And it's extremely important that you can build a solution around your 3D printer, because this will evolve over time. I don't know of a single customer that is where the customer was when they started. You always evolve, you always grow, and this long journey can bring you everything you need in terms of part quality, but also the part cost. And working with a total solution approach is the way to get you there. Thank you very much. And Diane, do we have any questions?
do. Thanks, Alban. We have a few questions that came in. The first one is, how many times can powder be used for refreshment?
A good question. So it depends on your refresh rate and on the powder. So if you make the calculation, if you have a 50% recycling rate, it means that after two cycles, you already have only 25% of all powder, and after 10 cycles, it's only a tiny fraction. So powder that have a lower refresh rate, I mean, when you need to put a lot of new material, can usually be used forever. On powder that have a lower refresh rate, sorry, higher refresh rate, meaning that only you just need to add a few new material, you will be using the powder again and again. But usually, if this powder accepts the addition of less fresh material, it means that they are robust. And so I can give you the example of the TPU. You could run it forever. And even if you were to do 2 consecutive jobs without adding material, that would still work. On the medical grade, though, because of the certification, we usually recommend switching to a brand new bucket of material after 8 jobs, and that's a way to guarantee that you stay within the certification. So it depends on your application, but most of the powder will be able, with the right refresh rate, to continue running in the printer.
Great, thank you. The next question that came in is, can you comment on the impact of a low refresh material little quantity of virgin powder needed for each production run, in parentheses, on the productivity and SLS?
Well, I don't see a direct link between, maybe I don't get exactly the question, but the refresh rate is determined on our side by what is the amount of material that you need to mix with old material, so virgin powder versus used powder, so that you can meet the material target. So we're talking about how make sure that you can process the powder in the printer. It will not give you surface finish issues, but also you stay within the mechanical properties that you're expecting from that material. But then once this mix ratio has been determined, you will run the printer with the same productivity. So meaning that you cannot decide to play with the refresh rate and compensate with the speed. Meaning if you put more old powder, maybe sintering at a lower speed will help. That's usually not something that we're using. So the target is more to define the refresh rate from the usability and material property perspective, and then run at the appropriate speed. It's true, however, that some material will not accept the maximum theoretical speed from the laser because of heat absorption effect. And if you take the example of the PP, it's the material that need a minimum layer time to absorb the energy from the previous layer before we can put a new layer. So if you have a very short build with a single part, there will be some additional buffer time. If you have a full build with that is full of parts, just the sintering time will be enough for the printer to absorb that heat. So it also depends on how many parts you have in your job.
Perfect, thank you. We have a lot of great questions coming in, but we've got time for a few more. This question came in from Miguel Perez. When you always have the same part, is it clear to calculate or predict cost with your explanation? However, how do you calculate the cost per part when you don't know in advance what other different parts is going to be printed in the same build job?
Yes, and that's a very good question, and we're getting to the, I would say, everyday life of printer owners. So clearly, on a resin printer, that's easier because your print speed will depend on the altitude of the tallest part, and also if you're using the full platform, only one part of the platform. So I would say having a quick estimate and rule of thumb of how fast will it print, and then you can get the volume of your part, that would be fairly doable. On the laser sintering, the nesting density can move from 3% to 10%, so which is how much of the volume you're using. The shape of the part might totally change indeed your build time because you have one taller part. So the ability to evaluate this productivity is more difficult. What I recommend in that case is to create a typical job to relate to in your daily operation. So typically you want to create what would be the big job, and that's the full Z capacity of the printer. Use an average nesting, something around 7% is a good estimate. So assuming that 7% of the volume will be sintered, and that will give you a good guess of the volumes and the productivity. And a good guess might be enough, because if you have a 10% variability in your guess on the 3D printing, if you add the refresh rate, which is how many new material you will need, that will not be related to how many parts you build. If you take into account your decaking and finishing step, that extra time that will not depend on 3D printing, that will be enough to give you an estimate of the ROI of your project. And then you can create a ROI for the some orchestra would call it the quick job. It's a 10-centimeter job that allow them to quickly launch parts, and they know what is the ROI of this quick job and how many parts they can usually fit in. But indeed, I agree. It needs experience to build this ROI based on the variability of the production.
Great, thank you. We have time for one more question. This one comes from Brian Hastings. How accurate is the P1000X across the whole build area, side to side, top to bottom?
We work to maintain the same accuracy across the entire build volume. There is a zone that we remove from the border of the, I would say, the mechanical part of the printer. So the entire build area that is moving and accessible is not included into the full build volume that we recommend to maintain part quality and accuracy. In terms of the altitude, the full build with the right thermal control that we have in the printer, it will always be printing at the same area. So your platform is going down, but where you print is the same area in the printer. So you will not see much difference in the Z direction. In X, Y, there is your laser beam is going to tilt in the corner. So there is a small angle in the laser beam. There are optics to compensate for that distortion so that we maintain the spec that we announced for the beam spots. But if you were to manufacture the smallest possible hole in a part, indeed you would want to qualify that more in the corner of the platform and in the center, because you might see a tiny variation. And it depends again on your application. If you print always the same parts, you will be able to find the right parameter set to always get what you want and make sure that you get the repeatability, and you will see always the same quality everywhere in the platform X, Y, and Z. If you have variable parts, anything coming in, usually you want to play on the safe side and not push it to the most detailed capacity of the printer, and make sure that you know you will get everything right on every single job. So again, it's application dependent, but we advertise technical capabilities that are proven on the full XYZ range of the printer.
Great, thank you. Unfortunately, that's all we have time for today. Thanks, Alban. We had a lot of questions that came in, but if we did not answer your question live, we will absolutely respond to you directly within the next day or two. So, Alban, thank you for your great presentation today. And once again, thank you to everyone for joining us. We know your time is valuable, and we appreciate your participation. If you want to know more about us, please visit our website at www.prodways.com. Thank you for joining again, and have a great rest of your day.
Thank you, everyone.